Welcome to Fabric Monday. Today we'll talk about using SCD Type 2 with copy jobs. We are talking about a slowly changing dimensions type 2. What's this? What's the importance of this subject? SCD Type 2 slowly changing dimension, they are essential to make the data trustworthy. When you don't use this kind of modeling, our data can become fake. Completely fake data. This is a risk that we always have when we rush the implementation and don't model the data correctly. The problem with SCD Type 2 is that it was always difficult to implement. No low-code tool was capable to implement it correctly. We had to implement by code. So, this is the level of importance of this video. The copy job in Microsoft Fabric is one of the first low-code tools capable to make the implementation for SCD Type 2 correctly. Let's see how it works. Let's start talking about what exactly is SCD Type 2 for the ones arriving now. Production keeps the data as they are now, so production supports updates of the data. If the customer, for example, moves from one city to another, we just update the customer record. That's what they expected. But when we start working with analytical data, we need to change this mindset. The analytical store needs to remember every state in the way that state was. We can't keep updating records because if we do, we will be creating fake data. This is the big danger of rushing the process. People who build production may not have the right mindset to build the analytical store. If they implement the same mindset for the analytical store, you can end up with fake data. Let's understand how this happens, what causes this. Imagine a customer, John. The customer in a specific date lives in Spain. The customer decides to order a bike and the order is recorded. The order is recorded in the moment that the customer lives in Spain. Then the customer moves. John moves from Spain to Italy. In production, the record, John's record, is updated. That's expected. But what happens with this data in the analytical environment? The order doesn't change. And the order is linked to the same customer, John. But today, John lives in Italy. So if we run a report analyzing the orders by each country, the order will be attributed to Italy, not to Spain. In this way, we have a fake historical information about that bike order. The data is fake because we allowed the update to be carried to the analytical store. The idea of SCD Type 2 is to prevent this kind of fake data inside the analytical store. And how the slowly changing dimension works in 3 steps. I'm explaining only the type 2. I will not go deeper on different types. So the source is updated. John's country changed from Spain to Italy. What happens when the source is updated? The change arrives from the source system. The record from John is now in Italy. We need to get the old record by marking John as being in Spain and mark this old record as expired. This old record was the current record before, and then we change the end date field and the is current field to mark this record as expired. It becomes a historical record. The new record will be inserted. Yes, John will be inserted again inside the customer table. John is inserted again with the new information that he lives in Italy inside the customer table. So we have in the customer table many records for the customer John, but only one of the records for the customer John is the current record, the current version of the tools. And about the keys, mind the keys being used in the records. We have a natural key 01, which comes from production and is carried on throughout the records. It's always the same. In this way, all the tables can link to this customer independent of the version of the record. And we have a surrogate key. The surrogate key is different for each version of the record. In this way, a specific data like the order can link to a specific version of the customer to keep a picture like a snapshot of the tools in the moment that the order happened. We don't have exactly a snapshot in the physical way of the database. We are creating the idea from the modeling. The order stays linked with one specific version of John's data, and this brings the reality from that version. The additional fields, start date, end date, student, helps to point which one is the current record, the current version of the reality, and when each version of the reality changed. Keep an entire track of how the Jones data changed in the system. In relation to the copy job, the slowly change dimension type 2 is always related to incremental load. We will not be loading out the data, we will be loading the difference, the change that happened since the last time the data was loaded. And loading the difference will reduce the amount of records we are loading, and together this implementation, the slowly change dimension type 2 is implemented as well. How the incremental load happens on the source systems. The copy job needs to identify when a change happened. It depends on the source system. Each source system has a different method to use that. That's why this kind of feature, incremental load and SCD, they appear for each source connector one by one. In this case, some examples. SQL Server. If we use some flavor of SQL Server, we can enable what's called change data capture. If we enable change data capture, the copy job will be capable to identify the changes. If we are using a lakehouse, for example, an environment in Fabric, we can enable a feature called change data feed in Delta tables. Once we enable change data feed, we can make an incremental load using a lakehouse as a source and taking the data to another point. This can be used to make a load from bronze to silver, for example. Or, if we don't have any of these source features, we can use a simple watermark. We can use a value that can be identified, and every record above a specific value in this field will be retrieved. It's like a raw version field. The copy job supports this kind of watermark field. We tell the copy job what is the watermark field, and the copy job will load the data and keep the highest value of this field and keep loading from that point. The option that will be used is picked by the copy job according to combination of the source and the method of ingestion that we choose. Let's see how it works. Let's see how the copy job makes the implementation of incremental load with slowly changing dimension type 2. Here I'm connected to an Azure SQL database where I have a table called product. I need to enable the CDC change data capture in this database. We need to enable the database level and we need to enable in the table level. So CDC-enabled DB, CDC-enabled table. One very important detail is the option that needs to be used supports net changes. CDC works either with this option or not, but the copy job only uses the CDC from SQL database if this option is enabled. This is very important. What does option actually do? Imagine that you have an ingestion from 3 p.m. and 4 p.m. 2 times of ingestion. In the middle of this time, a record ID 10 changes twice. What will happen at 4 p.m. when the ingestion happens again? Using this option, support net changes, only the last change of this record will be retrieved. In this way, the record changed twice in the middle of the ingestion. Only the last version will be retrieved. That's what's called net changes. This is a specific behavior enabled on CDC in SQL sources like Azure SQL Database, for example, and is required by the copy job. Here we can see our workspace in Microsoft Fabric SCD Type 2 video, and I have a lakehouse that I use as a destination of the data, and we will create a copy job to copy from the Azure SQL to this lakehouse. Let's create a new item, copy job. Let's call it SQL copy. Let's choose Azure SQL as the source. I'll specify the server, the database, and specify a new connection. Use organization account, my account, and next. Let's choose the table to copy, which will be the product table. Next. The destination is a lakehouse. Here we have the target lake, which already exists in the workspace. And I'll choose to make an incremental copy. An incremental copy is essential for the SCD Type 2. It's not possible to do it with full copy. Then I need to choose the write method. I will change the append by the SCD Type 2. SCD Type 2 is a write method for the table. It asks for the key columns of the table so it can identify the record changed in the source. Column name, let's choose product key. Next. Now I need to define the column mapping between source and destination. This is an optional step. I can choose to define this step or not. Column mapping, it's showing the columns and mapping these columns to the target. The mapping was automatically defined. It's okay for me. Then we can click next. Start data transfer immediately, and we can schedule the execution. Let's just schedule for every 15 minutes is okay. Save and run. We can note on the column load type that a full load is being executed. The copy job is already intelligent enough to identify that this is the first execution, the first ingestion, and it needs to execute a full load. Successfully executed. Here we are looking at the content of the lakehouse, the result of the copy. The table product was created inside the schema DIN. So the schema was created in the target and the table product was reproduced in the target. Then we have the exactly fields of the table product, plus we have some specific fields related to the copy job. Here, copy job valid from, valid to, and is current. These three fields define which record is the current record for the bicycle product in this example. Yes, the table in the source had only one record, only for the example. Back to the copy job, let's see what happens when we execute again, when we have no additional changes in the source data. The second execution, the load type points as incremental load. The copy job identified the full load was already done, and now it's time to make an incremental load from the source. We can note the lower an upper bound in relation to the incremental load. This information is related to the log identification in the SQL database. It's done in the format of incremental load and nothing was retrieved because there was no change in the source table. Back to the connection with Azure SQL, we can see the record in the source table. Let's change this record, change the list price on this existing record and add a new record as well. I will add a motorbike and change the price of the bicycle. So make these two changes, the insert and the update. Execute, it's done, executed, let's select, and we have a change in one record and we have a new record. Let's see how the copy job will react to this. Back to the copy job, let's execute again. One more time we have an incremental load, but this time we have 2 rows retrieved and 2 rows written. Let's see the result in the lakehouse. Here I'm looking at the table in the SQL endpoint right now. We can see the result of this execution of the copy job. Let's analyze. We have 2 records with product key 1 and 1 record with product key 3. The motorbike is the new record, this new record was included. The bicycle had the price changed. So in this way, the old record with the bicycle was set as finished. Copy job value 2 and an end date was set to this record. The new record received the new list price and has the copy job value 2 empty. We can see the difference on the changed price. In this way, we keep 2 records with product key 1, but each one has a different information, and only one is the current record valid at the moment. In this way, we keep the history of the information of the changes on the dimension, and in this way, we have a link from these changes with the actual order, and we know the order is linked with the right record, with the right information. Otherwise, we keep updating the records in production and the old orders will be linked with fake information, which is not true anymore. Using SCD Type 2, we can keep the integrity of the truth on the information. Thank you very much for watching and see you next week.